So this video tutorial is to show how to solve trigonometric equations involving compound angles. So the equation we are to solve is this. The cosine of x plus 225 degrees is equal to 2 times the sine of x minus 60 degrees for these values of x. Values of x from 0 until 180 degrees. So compound angles, the angles that we have are compounded. Addition, subtraction. So how do we start solving for the values of x? So we look into the left and the right side, and we can see here for the left side and the right side, we can directly apply the compound angle formulas. So the left side becomes this. We just apply the formula following cosine of A plus B. That's going to be this. Equal to 2 times. So for sine of x minus 60 degrees, we follow the formula for sine of A minus B. So it becomes like this. Okay. And then from here, we simplify. So those that we can evaluate in the calculator, we do so. So those are cosine 225 degrees, sine 225 degrees, cosine 60 degrees, and sine 60 degrees. So we will substitute the values from the calculator. Make sure your calculator is in degree. So the first value that I should get is cosine 225, and that is negative square root of 2 over 2. So this will become negative square root of 2 over 2 times cosine x. I write it in this way such that this becomes the coefficient of cosine x. Then minus, so sine 225 degrees is also negative square root of 2 over 2 there times the sine x. Again, I write it in this way that it's a coefficient of sine x equals to, so 2 times, now we get cosine 60 and sine 60 degrees. So cosine 60 is 1/2. So this becomes half sine x minus, so cosine 60 now. Sine 60 degrees is square root of 3 over 2. So this becomes square root of 3 over 2 times cosine x. Alright. So this is what we have. Now at this step, we can see that in both sides, we have sine and cosine. So let's simplify further the left side of the equation. I will multiply this by 2. So I'll get sine x minus square root of 3 cosine x. And then the left side can be simplified as, so this becomes positive square root of 2 over 2 sine x minus square root of 2 over 2 cosine x. Oops, it's not aligned. Anyway, this goes here. Okay. Since we have a sine x in the left and in the right, so we can combine all our sine x in one side and all our cosine x on the other side. So it will give us square root of 2 over 2 sine x minus sine x is equal to square root of 2 over 2 cosine x minus square root of 3 cosine x. So the equation now becomes this. And then we can factor out our sine x. So we will have two factors. We can factorize the left side as sine x times square root of 2 over 2 minus 1. Also, we can factorize the right side. The factors are cosine x and square root of 2 over 2 minus the square root of 3. Okay. So, like what we have said, when we are solving trigonometric equations, there has to be a single ratio only. Right now, we have two different ratios, sine and cosine. So, what is the trigonometric ratio that connects them both? That is tangent x, because tangent x is sine x over cosine x. So, we manipulate this equation so that we get tangent x. So, it becomes, left side becomes sine x over cosine x, and the right side becomes square root of 2 over 2 minus square root of 3 divided by square root of 2 over 2 minus 1. So, from here, we can now see the tangent x. The value of tangent x will be this ratio, which we can calculate using our calculator. So, I have square root of 2 over 2 minus the square root of 3. I'll put it in brackets, all of this. This one. Divided by square root of 2 over 2 minus 1. What's the bracket? And that give me, okay, this is not an exact value, so we'll just approximate this to be 3.50, correct, to three significant figures. So this is approximately tangent x 3.50, correct, to three significant figures, because it's the value that we got. Alright, so now we can solve for the value of x, and the value of x that we need is between 0 degrees and 180 degrees. So how do we do that? Again, from here we get the basic angle for x. The angle here is x. The angle here is also x. So we do not need to change this domain. So the basic angle for x is shift tan of 3.50. Again, when we do this, make sure your calculator is in degree mode, because the angle should be in degrees. It is in degree mode, so I'll do shift tan of 3.50, and I got, correct to one decimal place, 74.1 degrees. So the basic angle is 74.1 degrees. Now, we will use this to find the values of x that we need. Tangent x is positive, so we need to remember where tangent is positive. So, tangent is positive in quadrants 1 and 3. However, we will not consider quadrant 3 because the values of x are only between 0 and 180 degrees. So that means our answer will only come from quadrant 1. And that is your 74.1 degrees. So that's the value of x that will solve this equation for this given domain. 74.1 degrees.